Hello and welcome to another Portworx demo. My name is Bhavin Shah, and in this present demonstration, we're going to talk about how you can use Portworx Data Services to deploy a highly available Cassandra cluster on a Red Hat OpenShift Kubernetes cluster. Red Hat OpenShift is just one of the different Kubernetes distributions supported by Portworx Data Services, and Cassandra belongs to a wide catalog of different data services that Portworx Data Services supports today. To deploy a Cassandra cluster, just log into the PDS portal, which can be accessed using prod.pds.portworx.com. And as soon as you log in and select the organization and the account that you want to use, you will be directed to a dashboard where you'll see a list of different data services that you might have already deployed. As you can see right now, I don't have any actually running. And then a list of data services that are available for you to deploy on your Kubernetes cluster, or in this case, your OpenShift cluster. So let's select Cassandra as the data service for this particular demonstration. And here you can select a few things. You can select the version of Cassandra that you want to run. So let's just select 4.0.4 as the latest version that's supported by PDS, and give our Cassandra ring a name. So let's just call it Cassandra-DB. And then you can select your OpenShift cluster from the drop-down menu for target clusters. So once I select the OpenShift-cluster, PDS will go and fetch a list of all the different namespaces that are eligible for me to deploy Cassandra in. So if I go and look at that dropdown, I can see that there is a Cassandra-demo namespace that I want to use for deploying this Cassandra cluster. Once that's done, the next step is selecting application configuration and resource settings. So application configuration allows developers to choose runtime parameters that will be passed by PDS for that particular data service. So for example, with Cassandra, we have a small heap being configured. And if we click on show details, you will see that basically will translate into the heap size being configured as 150 megabytes and a max heap size of 1.5 or 1500 megabytes or 1.5 gigs. I can select medium heap, and that has a different set of parameters. Since I'm just doing this for test dev, I'll just select a small heap configuration. And then I can select the size. So this is the size of the pods and the persistent volumes that PDS deploys for my Cassandra cluster. Here you can see that small has a resource quota and a limit of 1 to 2 CPUs, 2 gigs to 4 gigs from a memory perspective, and each pod will have a 100 gig persistent volume attached to it. Once I select that, I can select the number of nodes that I want in my Cassandra cluster. Let's select 5 as the number of nodes because I do want high availability and make sure I have enough Cassandra nodes for the amount of traffic that I want to drive. Once I select that, I can select storage options, and this by default PDS has a couple of storage options, but this is again customizable by an administrator in your organization, or even if the developer has admin privileges to the Portworx Data Services portal. Let's just keep it simple. Let's select XFS as the file system and a replication factor of 2, and the volumes will be spread across different nodes based upon best effort. Once I do that, I can select whether I want to enable backups for this Cassandra instance or not. I can select full hourly, daily, and weekly backups at a time. And then even if I don't do it at day 0 during the initial deployment, I can always go back and schedule backups for my Cassandra instance. And these will be application consistent backups with all the 5 replicas being backed up at the same time. So let's do a full hourly backup, and then I can select the backup location. Again, this is something that an administrator can configure for me because they have to think about where these snapshots are stored in terms of regulations like GDPR or any other compliance regulations that they might have to follow. So as a developer, I don't need to worry about where the data is stored. I can just select backup bucket, and I know that somebody in the organization, or even like the developer himself or herself, has configured this as the backup target. Once I have selected all of these things, I can just hit deploy, and PDS will initiate the deployment of a Cassandra cluster on my OpenShift cluster. You can monitor the deployment using the PDS user interface, or let's go ahead and switch to a CLI session for our OpenShift cluster and use kubectl commands to do a kubectl get all in the Cassandra-demo namespace. Here you can see all the different resources that are being deployed for our Cassandra instance. You can see we have a stateful set being configured with a replica count of 5. Right now, we don't have any of the pods actually running, so it's 0 out of 5. But as more and more pods keep coming online, that number will change. We also see a lot of service objects which are responsible for communication, for the node-to-node communication inside my Cassandra cluster. In addition to these resources, we also deploy persistent volumes, and this will depend on the resource setting size that you selected. So we selected 100 gigs of persistent volume per replica, and that basically configures like to a 94 gig capacity of a PVC for each pod that will be running as part of my Cassandra cluster. We also, Portworx Data Services also configures a unique storage class for each different data service deployment, and these storage class definitions have specific parameters configured that are needed for that Cassandra instance. So for Cassandra, we might set a different IO profile than the IO profile that we set for something like a Kafka instance using Portworx Data Services. Instead of having our users worry about all of those different parameters, for them, it can be a very simple parameter that they set, like how many replicas do you want and what kind of file system, and that's it. Portworx can take on the heavy lifting of actually configuring those additional parameters that are needed to ensure best performance out of your Cassandra cluster. Let's do a get pods and see how our pods are doing if we have at least one replica that's up and running, and we can just put a watch command on it with the -w flag. So as you can see, our first Cassandra node is online, is up and running, and we're going through the process of setting up the second, third, and fourth and fifth nodes part of our Cassandra cluster. Once this is done, we'll be able to go back to our PDS UI and look at the progress from the user interface as well. So here you can see that one node is up and running. The second node is coming online. So let's just go back to our CLI session and wait for all the pods to come online. And now we are back. So all of our 5 pods in the Cassandra cluster have been successfully deployed. So let's just do a kubectl get pods in the Cassandra-demo namespace. And you can see that all 5 pods are in an up and running state. Let's do a node tool status command for one of our Cassandra instances. So let's exec into one of those. Let's just select the 0th pod in the Cassandra demo namespace, and then just pass the node tool status command as the command that we want to run. As you can see, all 5 nodes or all 5 pods are up and are in the normal state, participating in the same Cassandra rack. So that's how easy it is to deploy a Cassandra cluster from Portworx Data Services on a Red Hat OpenShift cluster. So that was day 0 operation, right? It worked out perfectly. But what about day 2? Day 2 is a huge problem for organizations that are still new to Kubernetes, still figuring out how operators work and how these different features are. Let's say I wanted to scale out this Cassandra cluster, right? How do I do that? To do that, all you need to do is come back to your PDS instance or PDS portal, navigate to the database or data service that you have, click edit, and here you will be shown a list of nodes that you have currently. Let's say I want to increase the number of nodes, right? Instead of a 5 node cluster, I want a 7 node cluster. All I need to do is come here and hit apply, and Portworx Data Services will communicate back to your OpenShift cluster, update the stateful set resource, add a couple of more replicas, and start the deployment of those 2 new pods. So let's switch back to the CLI. Here we can see if you do a kubectl get pods in the Cassandra namespace again, Cassandra-demo namespace, you will see that our changes will take place really soon. We don't see any active pods right now or actively deploying pods right now. So do a kubectl get all. And here you can see that our stateful set object has been updated. It shows that it now needs a desired state of 7 replicas, out of which only 5 are up and running. So at this point, OpenShift will take over and then perform the scale out operation by adding a couple of additional pods to this instance, to this cluster. So for that, let's do a kubectl get pods in the Cassandra namespace, and then just put a watch flag on it. So here you will see that the 5th instance, which is if you count from 0, it's the 6th instance, is already close to being in a fully functional state or a fully running state. Once that's done, we'll see the next instance, the 7th instance, come online as well. And once both of those pods are up and running, we'll again do the node tool status command to show that we added more resources from a Kubernetes perspective, but we also made sure that the Cassandra cluster recognizes these 2 new nodes and has scaled up and can accept more traffic from our application. So that's how easy Portworx Data Services makes the day 0 and day 2 operations for different data services running on Kubernetes, and in this case, Red Hat OpenShift. And just like that, we have scaled our Cassandra cluster from 5 nodes to 7 nodes. If we do a kubectl get pods in the Cassandra-demo namespace, we'll see that we have 7 replicas for our Cassandra stateful set. Let's exec into one of those and run the node tool status command again. So let's copy that and then select the correct namespace and share the command node tool status. So here you can see that all of our 7 nodes are in the up and normal state, and Portworx Data Services has allowed you to scale up your Cassandra cluster without even having to log into the Cassandra cluster itself. So that's how easy Portworx Data Services makes the day 0 and day 2 operations for any data service that you deploy on your Red Hat OpenShift cluster. That's it for this demo. Thank you for watching.